Alrighty, welcome everyone. Welcome to my session, Beyond console.log. My name's Aaron Powell, and kind of the reason or the catalyst for me wanting to do this presentation was I do consulting work, and so I'm often working with people that are new to web development or haven't been doing it for a particularly long time, or have transitioned from maybe server-side development into front-end web development, and the only thing they seem to know what to do with browser dev tools is the console.log statement. And all they can do is they can output an object or they output a string. So I wanted to put together a talk where we explore some of the other things that you can do with browser dev tools beyond console.log, some of the other things that happen in there. But first off, I just wanted to start with a bit of a history lesson about browser dev tools. So I've been working on the web for about 11 years now. So I remember the good old days of like IE5 and IE5.5 for Mac and Netscape and stuff like that. And I remember back when we didn't actually have dev tools. This is one of the first, if not the first, of the major dev tools that was ever released. It was the IE Developer Toolbar. That came out in 2005, or a preview for it was done at PDC 2005, and it was available for IE 6 and 7. It was, looking back, it was not great, particularly compared to what we've got now, but at the time, it was fantastic. Before we had something like this, all we could do was right-click view source, and that was the HTML. Excellent. That was how we had our DOM inspector, was view source. If I actually wanted to see what the styles were on an element, well, I was going to have to write something, a bit of JavaScript that would run at the end of the page and find the element in the DOM that I wanted and output some information of that onto into another div or do an alert or something like that. And it was alert-based debugging if I was trying to do any kind of debugging. And this thing, for all its problems that it has, and it had when IE6 hung around for longer than it should have hung around, in its time it was great. But what it really did was it started the kind of a revolution, the idea that developer tools are really important for web developers. And that's where we saw some tools like Firebug. Firebug for me was when it changed. It wasn't, developer tools were no longer this supplementary thing, a thing that it was an afterthought by the browser vendors. Firebug was originally a FireFox extension written by some people on the FireFox team, but it brought this really dynamic, interactive development experience to the browser, which has then evolved into what we have today. So I'm going to be focusing on evergreen browsers, in particular Chrome, Edge, and Firefox. I'm sure that Opera has developer tools. I'm sure that there's someone out there that's using them, and I'm sure that person doesn't necessarily work for Opera, or at least not anymore. And Safari, look, I don't have a Mac. I've heard they've got developer tools as well. I've heard that they're okay, but most people I know that are using Macs are not using Safari anyway. So like I said, I'm going to focus on the three browsers that, if we're doing development and we've been in Microsoft shops, we're probably most likely having a Windows-based machine, so Chrome, Edge, and Firefox. So to start the talk, I want to focus on the beloved console object. That's kind of, like I said, the catalyst for where this talk was starting with the console and the console.log, and I wanted to start with what are the other things that we can do with our console object? It's got to be more than just being able to do a log statement. And this is all the different methods that we've got on the console object. This is currently running in Chrome. So this is what we get if we do a for of loop across console object. We have a heap of different things. We do have our log method, it is in there, but we have a whole bunch of other things that are useful for different kinds of development that we're doing and different kinds of debugging analysis that we want to do. One that I find is really useful is the debug assert, console assert. What that does is it takes two arguments, a truthy statement and a message to output when that truthy statement fails. So we can litter our code base with this, have variable tests or any other conditional tests that we might have within inside of our application. If that's successful, that statement is just ignored. We never get a message out. It's only when that's invalid that we get that message out. It's really good when combined with test runners, so that we get our expect fails at the end of the test. But what was the information that we had leading up to that? What were some assumptions that we had within inside of our code base that resulted in that we can output to the user? Grouping's really powerful, particularly when you start plugging into middleware-based systems, be that React, Angular, or any of the other popular front-end frameworks that are popular for the next half an hour until we go write some new ones this afternoon. Plugging in something like a group that when a method starts and ends, we create a group for that. We can then put all messages that happen after that, be they assert statements, log statements, info, warn, etc., etc. They all fall under that group, and we can expand, collapse, hide that group if we don't need to see that information and look at other parts of the debugging that we get. Timing is also really useful if you want to say do very simple profiling against what's happening within inside of your application. You start a timer and stop a timer. You give a timer an ID so that they can be used across multiple scopes within inside of an application. So you can profile a single function. You can profile a pipeline within your application. And table is actually one that I always forget is there, and I'm constantly using something like console.log and putting information out. Table, if you've got an array of data and you've ever tried to inspect that, particularly a large array of data that you're looking at within inside of the console, and then you expand, and then you're like, oh, actually, no, let's have a look at the second item, expand. Table flattens that array down into a table of data so that we can inspect that in a whole lot easier manner. So the way that works, so I've got a couple of simple demos here. This one's I'm combining groups and different ways we can log out messages. So inside of here, I have the joys of doing live demo coding and running something with inside of a browser on a awesome Wi-Fi network is whether or not your scripts actually run in the background. So here we go. I've got an Ajax call that happens. It starts a new group, which is based off of an argument that I've passed in, or that group name could be anything. An Ajax call responded, and I've tabled out that information because I know it's going to be an array. But you can see this is a whole lot easier than if I just had that object structure and I wanted to, what is their Twitter handle, or what is the email address, having to look at each of those for every individual person if I had a very large data set that I was working with. So this is, and here we can start seeing how groups can become useful, because I've now done 2 different requests, and I can see, oh, actually I'm no longer interested in that one. Rather than reload the page or clear the console or something like that, just hide that information out. So you can imagine in obviously a larger application, we're executing a whole bunch of different code, have a whole bunch of different groups that represent the context of what we might be interested in analyzing, interested in outputting into our log at our console window at the end of the day. Also got a timer that's been run, starts when the Ajax call starts and then closes itself off when the Ajax call completes. Closing off that immediately just dumps out the time in milliseconds of that took. Generally speaking, you're going to be looking at milliseconds unless you've got really like high network latency and you're doing an Ajax call, or you've got a really long running function. So that sort of information, like this is a great way that we can really enrich the way that we can get information out of our executing JavaScript to a debug window, essentially. So naturally, this is browsers, so there's going to be some things that don't work the same in every browser, and we're going to have some browser nuances. MS Edge actually has some fewer features than you see in something like Chrome or Firefox. Predominantly things around timelines. So the timelines are for the profiling tools that we'll have a look at a little bit later. There's a method called mark timeline, and it's also aliased as timestamp. These allow you to put check marks that will then appear within inside of your profiling session. So you can say, oh, something particular happened at that profiling point and you just want a check mark so you can easily find that point in time. If you're, say, doing a minute-long profiling session, you want to see like every 10 seconds you want a timeline, or you know that an asynchronous call has happened at this point in time. You want to mark the timeline at that so you can easily find it back when you're analyzing in your process. It also adds a method called select, so console.select, and that allows you to then reselect an element back into the DOM Explorer. So if you're writing some code, some kind of operation is happening and you're just executing that inside of a script tag, but you want to know where that relationship back is into the DOM node, you want to be able to like launch back across there without having to use the inspector or like inspect option within inside the dev tools. You can just use the console, codify everything rather than having to use the mouse to go back and find things. Also, interestingly enough, it binds methods, all the methods of console in Edge are bound to the console instance. And what I mean by that is, let's say I open up the DevTools here in Chrome. So I had an array of data, and I want to log each of those out individually, or maybe more accurately, I want to just dump each individual item within inside of that. Chrome actually throws an exception because it gives you a pretty poor exception message, and given Chrome's history of making really good exception messages, this is not great. Basically, it doesn't understand the scope because this scope of console has been lost because we've passed in a reference to the function that we're trying to invoke rather than an actual invocation of said function. Whereas if we're in, say, MS Edge, and there we go, we can kind of see that. So if I was to do 1, 2, 3, and do that same thing again, it's able to do that. So this means that, say within inside of our code, we could write a whole bunch of shorthand aliases for the different console methods that we might be using, and then just use that method on its own. Inside of Edge, that'll work. Inside of the other browsers, that actually won't work. You have to then do like your own bind on top of that. So as I said, you get not as great an error message if you're using that in Chrome and you try and just pass the method across. Chrome also gives you a warning if you use mark timeline to try and put profiling points in, that's been obsoleted. It's actually been replaced by timestamp. I'm not quite sure the reasoning behind that they've changed mark timeline and they've renamed it to timestamp. Chrome also doesn't have console.exception. This appears in both Firefox and Edge. It turns out that the reason that that's not in Chrome is because console.exception was what Firebug originally used for console instead of console.error. They eventually decided to normalize that as console.error across DevTools, but because Edge or Internet Explorer back in the day originally implemented all the feature set that was in Firebug, they've got that carry on. So console.error and console.exception actually work exactly the same way. There's also a really interesting thing that you can do. If you've ever been to Facebook and opened up the DevTools, you'll get this big red error message. And I only found out about that the other day. I don't tend to open up the DevTools while I'm on Facebook, but someone pointed out to me, they're like, oh, have you seen this error message? Because what you can do is you can actually style the console messages that you're writing, and this only works in Chrome and I think in Safari. I don't have a Safari instance that I can test with. Look at that, I've done a lovely red bit of text with Comic Sans as the font because Comic Sans. So that actually works with this feature of console.log, and this is actually a legitimate use of console.log. I've got a message of, I can provide different kinds of strings and different kind of string formatters. So there's a %C formatter that allows me to pass in some CSS that I want applied to that message that's being output. Now, the value that that's going to give you inside your application, I'm not entirely sure. I also did try and find out whether or not it can access the style sheet that you've got running of the web page that you're on, because I really wanted to make like a spinning console message. Turns out you can't. It's like, damn, that was really depressing for me. And I blamed the person that pointed this out on Monday and was like, hey, that's really cool. I'm like, damn it, now I have to debug Facebook to work out how they've done that so I can use it in my talk on Wednesday. Firefox, it actually gives you a warning when you're using the console methods in an unbound method like I showed before in Chrome, and tells you why you've received that warning, not just invalid invocation, which Chrome gives you. It also ignores the mark timeline methods because it's been, Chrome's marks it as obsolete. Firefox doesn't tell you it's obsolete, it just flat out ignores the calls. So that's something worthwhile knowing if you're doing profiling of your application and you want to relate things and do timeline marking. Always go with timestamp. It seems that mark timeline is deprecated and some browsers just don't tell you why or don't tell you that it's been deprecated at all. So how about the console itself? So the console object, that's available with inside of your executing JavaScript. You don't actually have to have the console open to see those messages or to have those messages captured. They'll just be captured in the background and kind of buffered until you open up the console. But the console itself has a couple of interesting things that it does. The first one is that for every element that you inspect inside of the DOM inspector, it creates a numbered reference for that. $0 will always represent the current element that's selected in the DOM inspector. $0 plus 1, or that represents the one before, and so on and so forth, all the way up to $N. So let's come through and inspect an element. Here we go, come down, pick that LI, jump back to the console, clear off our lovely Comic Sans message, but for $0, so that represents the LI. So I can now, let's say I had jQuery inside of here or something like that. I might want to interact with that DOM element. I can pass it through to a jQuery selector. If I'm using this in an Angular application, it makes it a whole lot easier to say find something that's got scope on it and then pass that through to the Angular helper that I can then inspect scope rather than having to write an element selector query myself with inside of the console. $1 represents the body tag because that's what I had selected prior to finding that LI, and $2 doesn't exist yet because I've only selected 2 items so far, 0 current, and then 1 being the one that I had before that. So that's useful, and that's across all browsers, and really really handy. And I've been doing demos or working with web developers and showing them that, and they're just like, what kind of magic is this? Where did you define $0? I'm like, but you didn't. Oh, that's actually just built into the console, so that's available there. That's not available with inside of a running script, just because the running script doesn't have context of the debug, the dev tools. In terms of browser nuances, we have this lovely one where in all browsers except for Edge, hitting escape hides and shows the console because someone has to be different in that kind of thing. So say I'm on the elements panel and I can escape and bring up the console so that I can work with those in context of each other. Edge uses control backtick. That actually does work inside of Chrome as well. I can bring up, but control backtick inside of Chrome doesn't make it go away. So I don't know why there's that stupid difference, but great for muscle memory where we have to have 2 different things that we remember. All right, so on to debugging. Now, being able to put all these messages that just execute while our application is executing is great, but sometimes you're actually going to have to debug code. Every now and then we do write bugs. I know, generally speaking, we try not to, but let's be real. Code's full of bugs. Source maps is something that's been growing in its the accessibility of it over the last couple of years. Essentially, a source map is debugging symbols for JavaScript or CSS. So if you're using a compile-to language, so Sass or less for CSS, you probably want to debug what you originally wrote. And that's the point of a source map, is that it will give you that translation back. Because if you've used Sass or less or any of the other compiled to CSS languages, things like nesting and variables and all those kinds of things are really powerful. But what does that actually become at the end of the day in our CSS selectors? With JavaScript, if you're using a compiled to language like TypeScript or, heaven forbid, CoffeeScript, or you're using some kind of library like React and the JSX syntax, which is just not valid JavaScript, that's not going to run in the browser. We want to be able to debug that original code. Similarly then, we have this ability to do multi-level source maps, which is where we take the source map of, say, a compiled to JavaScript language, which is then passed to a minifier. So we have this just one single line of JavaScript, which we're serving out to our users, which was actually made up of 50 files originally. Some of those files weren't written in traditional JavaScript language, they're written in something else, and we've compiled down. We want to be able to debug that original set of code, and that's the point of source maps and multi-level source maps. Essentially, they're like PDBs for JavaScript and CSS. So from a .NET analogy, they're what your PDB would be. Oops, not that one I want. Okay, so I've got an Angular, a React application here. It does some lovely things, but if I come across to here, inside of I might zoom that out a touch because I need a little bit more screen real estate. So I'm using Webpack to do my bundling minification here and doing all the dependency management. It also does the transpiling and all that sort of fun stuff. Now I have bundle.js, which is this large file that is what I'm actually executing in the browser. But I have this node here inside of the Source Explorer, which gives me a representation of, like, here's all the files that I originally started with. I have app.jsx, which is the code that I originally wrote, and you can see that this is JSX syntax. This is not valid JavaScript. It's been compiled down. So I can put a breakpoint here, and I can hit a breakpoint within inside of this code that I originally wrote, which is, that's been converted into heavens knows what at the end of the day, but I can still debug this as though it was the original code I wrote. This can be really, this has just saved my ass so many times, particularly if you have source maps and you've put those into production. You've served out this minified combined JavaScript file that would be a nightmare to try and debug. Well, I can use the original debugging symbols and I can get that back. A nice thing about the Edge Dev Tools relative to the other browsers is, debug, that's the one I wanted, is that they're really zoomed in at the moment. Really zoomed in. So if I've got my source maps turned on here, and they don't have like the Webpack column thing here, they just have this no domain. So let's go and find my particular file. Put that breakpoint there again, hit reload, collapse that bit down. All right, so it's told us here that it's detected that there is a source map and you're viewing the source mapped file. I can turn that off, and this is the code that's actually running in the browser. So I can go back and have a look at, so what's the actual code? I find this useful for just working out what is the code the browser is actually running, not necessarily the code that I wrote, because while I have a lot of faith in the code that I write, and I have a lot of faith in compiler authors, sometimes I want to understand precisely what they've done. So it's very easy in Edge to flick back and forth between source map and non-source map. In Chrome, you have to go into the settings, you disable source maps, and you have to close and open the DevTools again, which can be a problem because you lose context of your debugging. You break out of your debugging scenario to go back and forth between those two things. There we go. Another feature of the debugger that I find people really don't seem to be aware of is trace points. Now, trace points are actually an MS Edge feature. So if you're a .NET developer, you're probably familiar with the concept of trace points from Visual Studio. The idea is that it's a thing like a breakpoint, but instead of pausing your application at that point in time, it executes a bit of code in context. The idea is that you would be wanting to put out some log information or something like that, and that's and you've added that at runtime to your application while you're doing your debugging, rather than having to stop your application, add that statement in, and then restart your application. So that's the point of trace points. But as I said, it's actually a feature it's only in MS Edge. But we can actually simulate trace points by using conditional breakpoints in the other browsers. Now, this is a thing that we can exploit by the way all the console methods return an undefined. Now, in JavaScript, an undefined is a falsy value. The point of a conditional breakpoint is it will only break when something results as true. So if we execute a console method, so log or dir or assert or something like that, it returns undefined. That evaluates as false, so a conditional breakpoint doesn't stop. So we can always have these there. They're always executing. They'll just never pause our application. I find that it's a really good exploit. Or it's not an exploit of the way the debugger works. So if we were to say chuck in a conditional breakpoint here and just do console.props, dump out the props. So this is executed then in context of that function or that chunk of code that you're pointing at, the scope that you're in. So you've got access to the variables that are there, this scope. You won't have access to closures, things outside of the closure scope that you haven't previously used within inside of that function. So I wouldn't have inside of this particular method access to the actions that I'm importing on line 2 because I'm not using that already within inside of my render method. You see here a conditional breakpoint that turns orange. And if I run this, I have something that's dumped out here, and that's the insight into our props of my React render method. This is also a slightly more complex example of using groups. So groups can have nested groups within inside of the debugger, within inside of the console. So I've created some stuff that's nested and nested and nested, so I can collapse down groups that I'm only interested in, not the one called undefined, but load people underscore complete. Another thing that we can do with conditional breakpoints is we can actually execute multiple things by exploiting another feature of JavaScript, which is the comma operator. So I can use comma to chain up a bunch of statements, and the last statement in that is the one that gets returned. So I could do, say, another method, so NDC, execute that, reload. So now I've got two statements that have been done. So I could, if I knew I had something that was in an array of data, I could do a console table, and then I could do a console dir or a console assert after that, because I want to have other things that execute, and I want them all done within inside of that single line. I could also do something like I could open a group at the start of this render method. Oops! Oh, I just removed my conditional breakpoint. I could open a group called render, and we'll also do a time called render, because I want to know how long this render method is going to take. And then down there, here's one I prepared earlier. It ends that console time, and we'll also close that group, end render. Reload that. So there's each of our render calls. So these are obviously being fired off by React. They're automatically, we're just being able to inspect those, start them up, because it's all code that's just running within context of that function that we had executing, and we're able to hijack that, add the things that we want to add specifically. Just my code or black boxing, depending on which browser dev tools you're working with, they're the same thing. Again, it's if you're from a .NET background, you're probably familiar with the concept of just my code in Visual Studio. Essentially, this gives us the ability to ignore particular script files within inside of our application that we don't want to debug into. Who's ever accidentally hit F11 while debugging something and stepped into the core of Angular or the core of jQuery and gone, here we go. Tried to step back out and then realize that you're stuck with inside of like 3 methods deep, and you're like, bucket F5, I'm going to start again. So just my code or black boxing, like I said, depending on which browser you're referring to, allows you to mark files as things that you don't want to debug into. So let's just collapse that down a little bit, and inside of here we have some scripts, and you'll see that we have a little icon against jQuery. MS Edge does a whole bunch of detection about known libraries or known third parties files that you'd be likely to use within inside of your code, things like jQuery and Angular, Bootstrap, React, etc. And by default, it will turn them into library code, so things that were immediately ignored. Now, if I hit that, the icon that goes away, and I can now step into jQuery if I wanted to. But when it's marked as library code, let's just zoom back out. We'll pop a breakpoint there. I'll start that, and then if I hit step into, it immediately steps over that that particular function, because I didn't want to step into that selector call. I can now step into code. This is my own code that I've written. So if I do step into, I go into that. The other interesting thing is if we have a look at our call stack, you'll see that we have library code. So the anonymous function is where we just came from, but then we have library code. So so this is where execution has come from something that I've marked as library, or I've marked as a black box, and I don't want to step into. If I come through and turn off library code on jQuery, we now see that we have the expanded call stack. I had 2 method calls within inside of jQuery that happened that I was able to, I could have debugged into if I wanted to, but I don't want to. So I can mark that as a library. So that's in both Edge and Chrome. Chrome calls it blackboxing, Edge calls it just my code. Predominantly because the guys that write the Edge Dev Tools are the same people that write the ones in Visual Studio. So, performance tools. Now, this is something that's, you're not going to use these tools until you need to use these tools, and it's like WinDBG. You've always forgotten how you used it last time because you only use it that fairly infrequently. I have a random B with inside of my code, with inside of my slides. Excellent. That's that's not meant to be there, but okay. So the idea between performance snapshots is that we want to execute something with inside of our application. We know it might be taking a bit longer than it should be taking, but we don't know precisely what it's doing that's becoming really slow. So how do we work out where our app is spending time? Well, let me just reload this page here. I have a very lovely demo that I click on something. That should have happened a whole lot faster, like moving those around, particularly on the first request. So to do that, I've got the performance tab within inside of Edge, and we've got these same tools exist within inside of all the evergreen browsers. I'm just more familiar with the Edge ones, but there's stuff in Chrome that has some slightly different features, but ultimately they're attempting to achieve the same thing, which is showing you what's happening within inside of your code and being able to inspect where time is spent. I'm just going to start this up, hit that, and then hit stop. So we can see that over the course of the 3.5 seconds between me hitting start button and then stop, we had not a whole lot happen, except we had this big thing here in the middle, and that's the thing that's of most interest to us. So let's just zoom into here and pop that up into a full screen. So now I've narrowed down the timeline to a thing that I've noticed with inside of my performance run that is of interest to me. So something's happened here, and it's taken a bit longer, or it's indicated that there might be a performance bottleneck in here. I can start having a look at what's happened with inside of that particular point in time. So there's an indentation graph, which is what happened over time and how long things took. It's fairly similar visualization to what you get with inside of the network tools in all the different browsers, if you're watching all the incoming requests. Let's narrow it down a little bit further, clear out that white space. So we see we have something down here that took a long time, and it's highlighting the different kinds of events that happened. So this is a paint event, so it's caused by visual changes to the DOM. So Edge is telling us like what this particular thing is doing, and that's made up of finding the root element and then essentially a series of cascading CSS updates. We also have something that took a little bit of time up the top here, which is a style calculation, which is me interacting with the button. We have some layout stuff that was happening, and then if you could see the web page behind me, it would actually be selecting the appropriate element as I inspect through all of this stuff, but on this kind of resolution, it was going to be kind of challenging to look at all of that together. And this gives us a good idea of, okay, well, this is where my application spent time. And then start having a look at the JavaScript call stack and looking at what took time with inside of that. Now, admittedly, this isn't a particularly complex application with a complex bit of code, but we can see that 96% of the time was spent with inside of this particular method, and the majority of it was inside of some stuff like this, which is, it spent a lot of time doing CSS interactions, so doing some jQuery CSS stuff. So we can start drilling down to where things happen. We can see the file that it happened within. I can jump through to a particular line of code where that first started. In Chrome, this will also give you time at the different lines of code of like how long those took. So like performance snapshots then related back to the code of like this line of code took half a millisecond to run. This line of code took a millisecond to run. Those sorts of useful things that you can use to correlate between what's happening in your running application and what you're able to observe through performance metrics. If you're using something like the console.timestamp, those will appear with check marks across this. Not in Edge though, because Edge doesn't support that stuff. By random B. Okay, so how about some unique features, things that only exist in different browsers? Some of the different browsers have some features that only exist within inside of themselves, within inside of their dev tools, and these are kind of the top few that I like. So I'll start with Firefox. We haven't really had a look at Firefox yet, mostly because the dev tools in Firefox are very similar to the stuff that you get in Chrome. UI differences, but functionality-wise, pretty much the same. But there is one feature that is in the Firefox dev tools that I really like, and I have been known to use quite a lot because it's saved me from a fairly big annoyance that I have, and that's being able to execute multi-line code. So if you say you've got a file, you just want to, like, how does that run? Like, I want to like execute just a chunk of code, see what happens, and interact with a page or just test something out. Firefox has this feature called a scratchpad. So rather than trying to do this multi-line on this one tiny little with inside of the console window as you would in Chrome or Edge or something like that, Firefox gives us a lovely big editor for that. Okay, so with inside Firefox, we have to go into settings. By default, they turn off a bunch of their stuff. One of the things they turn off is Scratchpad. I've turned it on. And it then becomes a new, that's right, I forget that settings actually becomes a panel and you have to click off it, whereas I'm used to Chrome where you just close the settings tab. So Scratchpad is this point here. Just zoom that out here. So we have this lovely big editor surface. Great for, like I said, creating big chunks of code that you want to execute and test against. It also, so it executes in context of the page, so you can access the DOM and interact with that, but it can also just execute as a standalone script. I'm not going to use it in context of the page, so I'll just pop it out into a full window. It gives you, it's got some comments in there that talk about what the Scratchpad does, how you use it, Control R to immediately execute something. You can also then have an inline inspector of the code that you're executing, so you don't have to keep trying to write to console. If you want to do anything, you can run something inline. So if I was to create a person, first name of Aaron, last name, oop, I can't even spell my own last name. That's how on the ball I am today. Now, if I was to just do person and then do Control I get an inspector of that object, so I can have a look at that and I can play around with the object that's there and have a look at what's in it. This is good if I'm, say, doing an AJAX call and I want to just see the response of that. I can have a look at that. We've got a filter here, so I could type down first name and it removes all the properties that match that. Alternatively, I can do, so that's Control I will give me the inspector. Control L will call toString on whatever the last statement is and put that inside of a comment, which is really useful for the most of the things we're doing in JavaScript because we get object, because that's what toString gives us for pretty much anything other than just a simple value. So if I did first name, and then did, and now I get my actual, I get something useful there, but if I just did the object as you saw, we get back nothing of particular use. I can load up an existing JavaScript file. So if I've been working something inside of code or inside of Atom or whatever my editor of choice is, and I want to test that rather than copy paste back and forth, I can just load that file up. Makes it a whole lot easier. I don't have to write code in here and just save it straight out. So that's really useful. One of the downsides of this is if I had something that I was executing within the loop. So I'm just going to create a function. I'll create a generator function that will yield twice. And I want to be able to inspect what would happen when that generator function executes. So I've got something that's essentially executing asynchronously, and I want to see each of the values each time through. So I've got for x of gen. If I did that and then do Control L, it only gives me at the last execution because it's the last statement that gets run with inside of the code. That's what it puts inside of the comment. Similarly, if I did Control I to output that, I do have I can do console.log. Oops. No, Control R, that's right. So I can run that, but now I have to jump back to the console tab, and I see the values that get executed there, so I can inspect it inside of that instead of. So that's one of the downsides of the Scratchpad is that anything that is done with inside of a loop, you are then going to have to kind of swap back and forth between tools. But we do have the console there. And we can do split view. Escape doesn't actually work with inside of Scratchpad because Escape, it does have IntelliSense, and Escape collapses your IntelliSense. And so nuances between them, but I find this, like I said, really useful for trying to test out large chunks of code as opposed to trying to squish it into a single line of code here and then realize that that doesn't work. And we'll collapse that off. There's that. There's another feature of FireFox. I will bring it up and I will make sure that I have my thing on mute. I do have my thing on mute. Excuse me. Which is web audio dev tools. Let me just reattach that onto the side. Now, where was the demo that I had? Yes, so the web audio dev tools, I will be very careful about using them because if you've done anything with web audio, you've got to be essentially executing something inside of a loop, or otherwise you get this high-pitched squealing noise because it's just playing one single sound. The web audio inspector will show you the chain of audio elements that you've got connected to be able to interact with, what your oscillator is, what your pitch modification is, and what your audio destination is. This is useful if you're, say, building a game or building some kind of application that has audio functionality to be able to interact back and forth with. But it's a little bit difficult to demo, as I said. I don't want to blow anyone's eardrums out today, so come find me afterwards if you're interested in web audio and you want to, and I can do that in somewhere that won't have quite as high pitch, quite as surround sound. So onto everyone's darling development browser of choice, which is Chrome. Now I could spend like an entire talk just talking about the cool things about the Chrome dev tools. So we've got like their ability to do mobile device testing is fantastic. It's second to none. Well, no, it's second to actually testing on a device. But they have a whole bunch of other really unique and interesting features that they promote really well. But one feature that I've found that they don't promote particularly well is this idea of DOM mutation events. A DOM mutation event, basically it gives us the ability to attach a debugger when something happens inside of the browser DOM. And this can be something that's very frustrating, particularly if you're dealing with a JavaScript UI framework like Angular or whatever. Elements are appearing or removing from the DOM. You're like, hang on a sec, why did that go away? I expected that element still to be there. What caused that to vanish? So, jump over to something here, and now I have something that's just executing, and I have items that are appearing on screen. I want to work out, well, what's causing those to appear inside of the DOM. Now, I know that something is happening here. Here's one that I prepared earlier. But I know that something is happening to that UL. There's some bit of code that is modifying that UL that is then causing its tree to change. So I can right-click on the element and go to a feature down here called it says break on. I can break on different kinds of things. I can break on a modification to the subtree. So do that. We go. Automatically that attaches a breakpoint that is just waiting for something to happen to that, that DOM element and any of the children of that. I found, okay, cool, here is what's happened. It's gone, and we're doing an append child right here. So I haven't had to work out where this line of code is. Chrome knows where that line of code is by virtue of the fact that I'm calling append child, and can pause when that happens, take me straight to that line of code. And now it's just as though I'd stuck a breakpoint right in this particular point in time. As soon as you attach a DOM breakpoint, you get a new tab inside of your element inspector, which is DOM breakpoints, which shows you the ones that you've got set on. I'm just going to turn that off because otherwise it's going to break every second, and that will be very frustrating. When you've got DOM breakpoints defined, you end up with a blue icon against that element inside of the inspector. There are two other kind of DOM breakpoints that we can set. attribute modification. So say like classes are getting added or removed, other attributes are getting modified for whatever reason. You can pause when those happen, so get it to automatically break when those sorts of things happen, so it doesn't have to be subtree, it can also be that. Similarly, you've got node removal, so when that element is removed from the DOM, you want to pause on that because, hang on a sec, why did that element go away? And again, that can be really useful if you're using like an auto binding system such as you find with inside of Angular. All right. Let's close that because I don't need it to continuously tick away within the background. Now, MS Edge. MS Edge is, it's still kind of playing a little bit of catch up in terms of its dev tools. They're pretty much on par in terms of the common features. But in terms of unique features, there's one really interesting unique feature that I think I saw was popping up with inside of a Chrome Canary build, but I can't remember and I couldn't find where I think I saw that. So maybe I was dreaming about browser dev tools and that's my life. And the idea, and this is the ability to track changes with inside of your style editor. So as someone who does a lot of front-end web development and you're trying to make something pixel perfect, you're modifying CSS rules and it's like, sweet, it's done. Oh shit, what did I change? F5, start again, start writing down as I do the changes. So we'll use this page that I've got open here, which is going to be lovely and terrible to try and interact with. So let's just reload that page. I seem to have breakpoints still set. F8, continue on. Okay, so yay for DevTools not working. So this is one of the other unique features of the MS Edge DevTools is the ability to not render a DOM Explorer. I'm not quite sure why they've added this feature. I find it a little bit of a hindrance, particularly when I'm doing demos. But they have that feature there. Kudos to them. I would really like it if they removed that feature. So let's just try that again. All right, there we go. We've got a DOM Explorer. Excellent. Whoa, zoom too far. Okay, so let's find this particular element inside of our DOM tree. And I want to put some styles on that. Color of, this is the one color that I always remember off the top of my head that is very obvious and standoutish, which is F0A. It's a lovely fuchsia shade. Remembered that one. Or the other color I always remember is bad ass. Yeah. Okay, so I've done that actually. Well, let's create a new rule let's create a rule against all LIs, and that will have a font family of Comic Sans MS because Comic Sans. Oh, that's not right. Damn it, I can't remember what it is off the top of my head. Oh, Cosmic Sans. Sans. There we go. Yeah. Okay, sweet. So I've done a whole bunch of CSS changes. It looks amazing. My application is ready to ship production with its badass color scheme and its Comic Sans. But I need to work out what was changed. So there's this changes tab that that's within inside of the inspector. I can click onto that and it goes, well, here's all the style rules that we had. So green ones are things that have been inserted. If I came up to the body styles, let's remove that width. I'll see down here I've got something red that was removed. Let's do padding top to 30. And we get a very accurate looking diff. Like this is the diff that you would kind of see with inside of any decent diff tools, the red-green color scheme. The one downside of this, and it's a feature request that I've made when I've been talking to the guys that work on F12, is I'd love a way that I could export this as a JSON file or something other than, I can copy and paste this. But the problem is that as soon as I'm going to copy and paste that, I'm going to get padding twice. and I got to just then remove the ones that are no longer relevant. I'm also going to get the width still there because, well, it's been removed and copy and paste doesn't understand that concept of removal. I'd love some way that I could export this file or export this diff or click a button and have it sync back back to my original source file, particularly source maps and all tracks. I don't know how they do that with additions, but that's not my problem to solve. That's their problem to solve. The last feature, if I can remember where it is. So the last feature of Msh Dev Tools, I figured just while I've got them open, talk about that, is this special type of breakpoint. So they've got trace points, which is a specialish type of breakpoint. They also have another one here, which is called, I'm just going to remove these so I can get some more space. So it's a XHR breakpoint. So if I add this, this will automatically pause my application when an XML HTTP request comes back, when AJAX call completes. Rats, it seems like it's not been wired up to fetch. I've just started converting all my code across to using the fetch API instead of the traditional XHR, so like jQuery, AJAX, and stuff like that. It seems that doesn't break on Edge. On fetch, sorry. This is really useful though. Say you're using the Angular HTTP service, you're using jQuery to do AJAX calls, stuff like that. I can stick that, and that will cause the application to break when any XHR comes back. So you don't have to go hunting through your code to work out. So it's as soon as that request is finished, it will pause your application, and you can then start debugging from that point in time. That's all I had for today. I've left a couple of minutes for questions, or feel free to run off and get in the queue for food before the next session starts. I'll be around for the rest of the week. Feel free to pop by, ask me questions. I'll be at the Redify booth for most of the time, or shout out questions now. But thank you.
Can you recommend any specific tools for debugging React apps?
Yes, so I deliberately didn't talk about browser extensions and dev tool extensions here because that's opening up a can of worms. With React apps, the React Dev Tools from Facebook are really, really good. They give you a great visualization of your virtual DOM. If you're combining React with Redux, the Redux Dev Tools are also really fantastic. Actually, this is a React application, so I can bring that up pretty easily. So this is the React Dev Tools from Facebook. It gives me a visualization of my virtual DOM related back to the physical DOM, so I can, as you see, inspect through back here. But you also see my component hierarchy that I've got. I think this is a Redux application, but I don't have the DevTools enabled in that. But that's also really good if you're combining React with Redux. There's similar tools for Angular, the Angular Batarang. If you're using that, that's pretty good. It works for the most part. It has some really bad issues with tracking updates that happen and displaying those and expanding and collapsing objects within inside of itself. And I'm not a big Angular fan. That's a rant for another day. Cool. Thanks, guys.